So let's focus a bit more on measurement theory. Specifically, we're looking at what do we need to know about once we get our measurement, once we start seeing those results, how do we start interpreting those results? So these are the basic concepts that we need to start reflecting on those and how well they really tell us what we think they're telling us. So let's say I take a survey for depression and it's asking me several different questions. So there's a certain score that I'm going to get. Let's say my score is a 99. Well, that score is going to be a reflection of both my actual level of depression plus some error. We're going to look a little bit at what those errors are. If you're looking at it from a formula, which I'm sure you love, again, this isn't statistics, but this is your score. So if I get a 99, that 99 is just a number. But that 99 represents my true level of depression plus whatever kind of error shows up. And there's always error. There's always some kind of error built in, but we're going to look at what those errors are and how we basically account for them in a way that they don't mess up our results. So those two types, think about systematic. This is the visual we'll come back to. Systematic error means that it's consistently off. Random error is all over the place, and the fact that it's random makes a big difference, and we'll look at why. So systematic error almost always includes a bias. So let's say that I'm asking questions in a certain way that makes people answer differently than what they really feel. And if everybody answers in that certain way, then that consistently reflects a false picture. So let's look at an example. If I ask everybody the best way to ensure peace is through military strength, 55% of people will agree. But if I ask them to choose between the best way to ensure peace is through strength versus diplomacy, then only 33% of people agree. So the same question asked two different ways gets different results. Why? There's something called acquiescent response set. People are actually biased towards answering agree. Anytime you ask a question of agree or disagree, people generally don't like to disagree. It's called they want to acquiesce. And so that's a type of bias. So if I was to ask this question in a survey, almost everybody would be more likely to agree, and that would throw my results way off. Versus if I ask it this way, this probably is a much closer approximation. So here you see the true response is much lower, that 33%, so you get an error of 22% in this question. When you chart it out, systematic error looks like this. If this is what the blue is what it would look like in real life, then the red is what happens. So it's still kind of has more or less the same distribution of responses, but the average you see here is very, very different than what you would see otherwise. So random error is the one that so let's put it this way, systematic error is bad. It's bias, it throws off our results really badly. Random error, not so bad. We expect this. You usually expect both. Random error we can deal with using statistics, and we can kind of adjust for that. So let's say you just happen to take a test, and that one day you were just having a really bad day, so you just scoring, make it seem like you've got higher levels of depression. But randomly, there's also people that could probably be having better days than normal, and so they might inflate their score. So random errors tend to kind of balance out, and they tend to cancel each other out. That's why it's good. They're random, so they're all over the place. If it's random error, then reality might mean some people are showing up like they're really depressed. Some people are showing up like they're not depressed at all. But the reality, the average number of people that are depressed is still going to be balanced out, because these two extremes will balance each other out. So what are some of the errors in the different ways it measures? So for example, if people are writing, if they're checking something off, the way you ask it, so the words that you use, it could be whether you're asking people to do something, certain words, maybe in interviews. Maybe you're asking people to tell you about substance abuse. Well, people probably are not going to be as honest in an interview because they don't want to, they want to be socially desirable. Or maybe they respond to you differently than they do to a fellow interviewer. If you're observing it, again, people may act in a certain way when they know they're being watched, or you watching them might be expecting them to act in a certain way. If you're examining doctor records, for example, maybe that social worker or that doctor is going to make it seem like there's really low rates of depression because they want to make it seem like they're really effective, or maybe they just didn't input information in the right way. So there's several different ways that you could get errors in measurement. depending on how you're capturing that information. So what can you actually do to reduce that error? A few steps you can do. Pilot it, check your instruments. You usually, rather before you do a survey, for example, with a big group, do it with a small group and tell them, is there any questions that are confusing? Are there any questions you felt uncomfortable answering? Check those results. Make sure you train your interviewers so that everybody is asking questions in the same way. Maybe somebody's raising an eyebrow at a certain question or, frowning at a certain response. Make sure they're well trained. You want it to be unobtrusive, so you want to catch people in a natural element. In social work, we're not testing people in a lab. We're testing people in their natural environment, so stay out of their way. Double check, triple check, quadruple check your data to make sure you don't have any miscalculations, and triangulate. So that means use different measures. Maybe you have a survey and an interview, or maybe you have a survey and you observe people, and that gives you a better chance at capturing the true or getting closer to what you're actually trying to measure.